submitted our estimate to other places. So, yeah, so it's happened. So, yeah,
Right.
it's there.
Okay, so welcome back. Today we'll be talking about D3 maps, and this is actually a lecture that Carolina Norbre will be holding. Carolina is a third-year PhD student. She was a TA for the past twice before. Now this year she gets the year off. Any administrative questions? There's going to be a homework back tomorrow, as you probably saw on Slack. We moved the deadline for the next homework from Friday to next Tuesday to give you guys a little bit more time, because we realized that this is quite a step up from what we've done before. So now you really have to communicate between multiple views, and it's a fair bit more complicated. It's not a toy example anymore, it's real data. So questions about that? Okay, so yeah.
You said there was going to be another TA session on Monday?
Tomorrow, Wednesday, sorry.
Live tomorrow, but then I think you also mentioned extra TA hours.
Yeah,
We'll
just
be moving the office hours.
office hours will be adjusted so that you have some extra opportunity to go to office hours before the deadline. Just check the Google Calendar for the updated hours. So,
They will be up there.
we will update it. Other questions? Okay, so then Carolina, take it away.
Yes, like Alex said, I am a third-year PhD student working with him. I accidentally wore my D3 t-shirt today. It's actually very similar to D3 on Conf. I don't know if you guys have heard of it. It's a conference in San Francisco. A lot of people work in D3 in San Francisco, so it's an unconference, but it's very formal. But there's some big names. Mike Bostock showed up, and it's actually really fun. They have it every year. Okay, so I'm going to be talking about maps today. You guys have already done a map in a homework. No, we'll be doing a map in the next homework. So this is very relevant, and I've tried to put in as many little things that are relevant to your homework, and I'll point them out, so the parts that you have to pay attention to. What I want to start off with, as either Alex has already mentioned or will mention, is that maps are definitely overused. Use maps almost kind of like an easy go-to, sometimes when we don't necessarily need to use maps. The problem with maps is that you've used up your spatial coordinates, your spatial dimensions by encoding Latin long, right? So you have to put a dot in Salt Lake City, exactly where Salt Lake City lives on the map. And then you can use other channels like color or size, but you lose the position, which, as you guys have seen already, is one of the most important channels that you can use when creating a data visualization. That being said, there are times when it's absolutely appropriate to use a map, right? And I would just kind of summarize those times as when the location is important. If you want to find out in Google Maps where you're going for dinner, it's very important that you know the exact location. If you want to find out what Hurricane Florence has been doing, which is an example we're going to look at, the actual location is important. Within the scope of maps, there's kind of two big categories. There are data maps, and then the more, what we're calling street maps, which is the Google Maps, right? So when do we use one and when do we use the other, and what is the really big difference between them? So the thing with data maps is if you think, I don't know how much you guys read the New York Times, but if you think of their general examples of maps, they're data maps. And what we're calling them data maps are when you want to encode something on top of the actual, it's a very simple representation of the country or the state that you're looking at, but then you encode something else on top of it. Maybe the strength of the hurricane, maybe the number of people that have a certain disease. Whatever the story you're trying to tell, you're going to use the map just as a base, and you don't really care the street names, you don't really care the distances between point A and B, you just want to show a certain value, and you're using the map as kind of the base to tell that story. On the other hand, we have street maps, which are things like Google Maps. And in those you care really, it's very important that you have the exact Latin long, and maybe you want to calculate the distance between 2 points. Maybe you want to zoom in and out. One thing that we state here is that typically you can't zoom in and show more detail in data maps. When we say that you can't, we don't mean that it's physically impossible, because as you guys probably know at this point, you can set the zoom level and you can scale it using just the SVG, making it bigger and smaller. What we mean is that you can't semantically zoom in. When you zoom into Google Maps, it changes what you see, right? It goes from country to the streets to the actual number, and so it's a semantic zoom. And in data maps, usually you don't have that. It's a static kind of, and if you want to zoom in, you just make that bigger, but it doesn't change what you're actually showing. So that's kind of one of the differences between data maps and street maps. There's a kind of a third type of map, which Alex is going to talk about in after fall break, which we're calling them a map, but you really don't have. I'm going to give you a few examples. Let's see which one we'll show first. This one is an example. This is a map that shows the, I think it was 2000, what year is this? This is the 538 piece. Oh, this was recent, this was Hillary Clinton. So here what they do is they actually encode the size of every state by the number of electoral votes that that state has. So even though the positions of these states are approximately what they're like in real life, there is no actual lat-long value associated with each thing. And the point of this is to use a map-like representation so that the position still is relevant, but it isn't exactly encoded as you can find it in real life. And that way you can use the position, so bigger map, bigger states mean something, and they tell your story in a more effective way. So we're still calling these maps, but they're a different type, and we're not going to cover them in lecture today. But I particularly find them really cool, and I think that when you get to your projects, if you're using a map, to consider them because they can tell a story. You can use a position channel to tell even a stronger story for whatever it is that you're doing. Just a quick other example. Here we have one where all of them are the same size, so they're a little bit more faithful as far as the position goes. But then you can actually encode something onto each of them. So in this case, a little histogram or something to tell, in this case, it's probably, yes, it's an election one as well. And then there are a few other examples of how you can use map-like things to tell different stories. And so I just want to kind of put out there that that is another representation that falls within this general category. Okay, so we're going to start talking about data maps, which are, I'll give you a few examples, and then we'll end with the Google Maps. So this one I actually added recently, and this is the New York Times coverage of Hurricane Florence, and they have several different representations, all of them using data maps. So even though they're geographically accurate, as soon as that loads well, you see it, they only use the sketch because they really want you to know what the outline of the state is, but on top of that, they encode the strength of the winds, they encode the amount of rainfall and so forth, right? So this is one example of a data map that's being animated. You can see they use color, and you can't really zoom in, and if you did, it's not like you would ever get to the street level, right? It's just this static kind of zoom level, but it tells a very compelling story. Here's another one where they're sizing the circles by the number of customers that do not have power. Here's a different kind of representation where they're showing you winds. So one of the reasons this is so compelling is because you're able to take out all the information that's not relevant. If you ever try to use a Google map that for some reason has too many labels and too many things, it's hard to, on top of that, still tell a story. So these data maps are visually compelling. They require a little bit more work in the sense for you, the programmer, to put them together because you're dealing with the actual shape files. The Google map, as you'll see, very straightforward. You can create a Google map in 2 lines of code, and it kind of outsources all of the zooms and the pan and all that kind of stuff, but it comes with a lot of the visual pollution that maybe we don't want for a story. Here we have the track of the hurricane overlaid as an SVG layer on top of your map. So this one starts looking a little bit more like a Google map because you see it has a few more labels. And you can customize the Google Maps to have less labels, but you still lose a lot of the control over exactly how you color code and so forth. Okay. So those are just a few of the examples I wanted to show. Sorry, that was the first example. Here we have, well, actually, I'm not going to go through all of them for the sake of time. I'm going to show you my 2 favorites. This one is a piece from Flowing Data, and if you don't know Flowing Data, I highly recommend it. It's a really cool website with a lot of good stuff, where they actually show you the amount of bars versus grocery stores in different countries. So different states within different countries. So here you have in the US, Wisconsin has 2.7 times the bars as grocery stores. More grocery stores here. Salt Lake City looks like it's tending towards more grocery stores, unsurprisingly. France has 81% more bars than grocery stores, so they have their priorities straight, as does Spain. Poland and Germany, more into grocery shopping. Anyway, this is just kind of, it's a clean way of telling, in this case, a pretty interesting story. Okay, now I do want to warn you, the next 10 to 15 minutes are very boring. And there's no way we can make this interesting because it's talking about the GeoJSON format, but it is important to your homework, and it's important for you to understand when you're trying to actually use the TopoJSON GeoJSON feature, what you're looking at. So bear with me. We're going to be looking at things like this. They're pretty easy. I just want to put it out there, but not super interesting. So who here has heard of GeoJSON? Okay. Who here has heard of TopoJSON? Who here knows what the difference is? Okay, good. You're in the right place. You're going to talk about that. So GeoJSON is what we ultimately are going to work with, and we do, a lot of times files are TopoJSON like for your homework, and you will have to convert them to GeoJSON, and we'll talk about why we start off with TopoJSON, but at the end of the day, you want to get it to GeoJSON, and then you can use it for D3 and all the cool stuff. So GeoJSON is pretty much a JSON object that has lat-long points in it. That's pretty much it. And they can be as simple as something like a point, or as complex as a combination of polygons with a description associated to them. We're kind of going to walk through from the simplest to the most complex one, but essentially they're just objects that have points in lat-long space and that have some kind of name or ID or description. So the simplest one is clearly the point. A multi-point is an array with more than one point. A line string is an array of positions that will connect to form a continuous line. A multi-line string obviously is an array of arrays, each one of them containing a line. Polygon is very similar, but instead of a straight line, it can actually connect things that form a polygon. And the multi-polygon has several polygons. The geometry collection allows you to put together things that aren't all the same type. So you can have a point with a multi-polygon, you kind of all put that into one single object that later can be broken down. The thing that you're going to be hearing the most about are features. Right? So features are pretty much any of the things that I just described, plus an array of properties. So a very simple example is here where you have a polygon that describes a certain place, and then we want to actually tag that or give it a name. So one of the properties could be name. It doesn't have to be name. It could be ID, it could be color, it could be anything. It's just pretty much, hey, I have this thing in space, and I want to characterize it. And we're going to be using that from one of the homeworks as well, where you actually have to add a property to one of these points. So features are pretty much your building block here. You're going to be talking and hearing a lot about them. A feature collection, unsurprisingly, is an array with a bunch of feature objects. So here is a slightly more advanced example where instead of not only the name, you also have the address. So as you can imagine, this can just grow into it's complex an object as you need it to be, but it pretty much describes that point of interest. And you can use those descriptions or those properties to color things or to size things and really leverage D3's ability to take data and make it visual. So think that if you want a point to be sized by the number of people that live at that place or the number of bars or grocery stores or whatever it is, as long as it's a property in your data, you can then very easily with D3 color it according to that. So it's really the core function for us as visualization experts for that properties part of the feature. Okay, so TopoJSON is very similar to GeoJSON in its function, but not in the way that it's actually encoded. So if you think of the United States and think that if you're drawing every state as a separate shape, every time that two states are next to each other, you're drawing that line in the middle twice, right? So you can imagine if you're doing that for an entire country, for the entire world, there's a lot of duplicates. The idea with TopoJSON is saying, okay, we're just going to draw one as continuous line as possible, and then we're going to break these things up into arcs, and then things can share arcs. So the idea is, let me stop duplicating when I'm drawing individual objects, draw everything together, and later reference which bit of that line belongs to each object. So two states that are next to each other will share an arc, but that arc will only be defined once. This optimization can reduce your file size by up to 80%. So a lot of times if you're online looking for a GeoJSON or a JSON object that describes your whatever it is that you're trying to plot, you'll find a TopoJSON, and then we're going to show you how to make that into a GeoJSON, which is not as efficient, but is more user-friendly, especially in the visualization context. So just to give you an idea of what this file looks like, the TopoJSON, it tells you that it's, so this is if you open a TopoJSON like an editor, you'll see the type is topology. It has a transform object that has a scale and translate that's applied to everything, and then it has an array of objects. Okay? This array of objects references a separate array of arcs. So think of it as you drew this whole thing in a single line, you broke it up, you have an array of arcs, and then you have a separate array of objects that says, hey, you can build me using your arc at position 2, 4, 6, whatever. So if you open it up, you'll just see an array of indices. You don't really need to ever deal with this. This is kind of just how it's built. And then the library that we use to go from topo to geo takes all that and makes you a really nice GeoJSON object. Okay. So like I was saying, D3 only handles data in GeoJSON, so we use a library that can be included in your, and I don't know if we supply that already, that one line, we do, in the homework. So you don't have to add it, but that's the line that pretty much says, hey, this is a library that's going to take our topo files and make them into JSON files. I'll spare you the actual description of what that does, and you can read it if you like, and give you a few examples. So let's jump into how you actually use this. This is the syntax that you will be using in your homework. So if you're doing email or thinking about something else, this is the line. You know, always come back here. This is, this is part of the lecture material where you're going to use TopoJSON.feature. So you're pretty much saying, hey, give me a feature. And do you remember what a feature is? What's a feature?
Description.
I heard it somewhere from it. Can you raise your hand? Whoever said it? You have candy and I have to throw
It's
it.
like it's a description of an object on the map.
Yes, it has the lat long points and the description associated to it, right? So it's an object slightly glorified. You start at the back, there's no way I'm going to reach this. It's going to hit someone.
I'll come get it.
Okay, I'll put this in here. So if you were to console.log, what that does is you would get, in this case, since you have a series of objects, you would get a feature collection. You turn a bunch of them, and now you know what to do with that, right, in your, you can associate that to your data and actually get started with the actual. I want to clarify something here. This is what the syntax is. If there's a topology and object to be converted, and this is what that actually looks like if you're using dates. Now notice that we pass in the whole TopoJSON file, and then we actually pass in the array of things that we're trying to convert. What this function is getting from the TopoJSON is this bit here, the topology bit, the transform bit. And then you don't necessarily have to pass in all the objects. Maybe you only want to extract one state. So that's where here you would only put in JSON.object.utah. whatever. Okay, so you don't have to pass it all in. Your homework will use all of them, but just so you know, this is why it seems like you're passing it in twice. This is something that confused people in previous years, which is what am I passing into my .data, right? So you were able to convert your TopoJSON to GeoJSON, now you have an array of features, right? What gets returned, your GeoJSON here, is an array, is an object that inside has an array of features. So your .data isn't just GeoJSON, because if you pass in just GeoJSON to .data, you're passing in a single object, and you're not going to get anything. Especially if you don't put it around brackets, because as you know, .data takes an array of things. So if you only want to give it one thing, it would have to begin with brackets. So I see people put GeoJSON equals tuple.json.features and then feed GeoJSON into .data and nothing happens. So, and I think one way to circumvent that is really know what your data looks like. So do not be afraid of console.logs. Even as I was putting together this lecture last year, I would console.log every step to make sure of what it is that we're getting. So here, this gives you an object, and you want an array. Okay, you have been warned, anyone that comes to office hours with this problem will be turned away. So we've talked a lot about these objects, these features, these geometries that have lat long. And these coordinates are all given in lat long, but as you know, with the concept of projections, we need to put them on a map, and so it's not absolute, it depends on what the projection that you're using. So we're going to kind of go through and look at some of the ones that are supplied by D3, and I think, do we suggest which projection they use for the homework? I think we do in the,
Yeah.
So
We
you-
did, exactly.
Oh, so we give you don't get to choose, but if you want to play around with it, and it's just fine, you can kind of see what that does to your to story. It depends mostly on the scale that you're looking at. If you're looking at Salt Lake City, you will use, say, Mercator projection. And if you're looking at the entire world, you might pick another projection. So there isn't really a best one, it's a best one for your task, right? So here we have a very simple example, and I'll open this. I'm going to make this a little smaller so we can fit the whole example on the screen, where we have an object that have a lat long position, right? Here, we are defining a projection. And I'll show you a cool website that lets you iterate through all of them to see what they do. So we just picked one that's USA specific, so it really optimizes in what the United States looks like. So this is pretty much saying, hey, I want a function, a projection that when I give it a lat long is going to give me where I should put this on the screen, right? Because lat longs are numbers, but if you just try to put them on the screen as lat long, they're going to be way off where your SVG is supposed to be, because your SVG is just 0 to whatever your width and height is. So we need to translate world coordinates to screen coordinates, and that's what this is doing. So here we're going to say, hey, give me the projection that I just specified for the long and lat values, and let's see what that looks like. It's just a console thing, so super exciting. Your original position for latitude 38, longitude minus 83. Your projected position is position 662. You obviously can't forget to do that, or you will have no points on your map. So kind of boring, but important. These are all of the projections. Actually, I think there might even be more than these, right? Yeah, I think these are some. Yeah, these are some of the projections. And this is a really cool thing, which is it will pretty much just alter and cycle through them. And you can use the drop-down to pick a specific one, but it is an understatement to saying the projection you choose really influences the story that you tell. And some of these I've never even seen before. Okay. So, I'm trying to remember if you guys have used paths at homeworks up until now. You have used paths, right? So, unlike just a circle where you say this is the x, this is the y, we want to actually generate a path from each one of these, whether they're states, countries, whatever it is we're in. And that was a sentence that didn't sound like anything, so ignore it. We're going to use d3.geopath for that, right? So this is pretty much a path generator, very similar to d3.line or d3.arc, right? These are functions that take in points and give you a path, so you don't actually have to compute that horrible string yourself, m, yada, yada, l, whatever. So here, this is a very convenient one because you give it lat long points, and it gives you the path that you need to draw. So let's look through a very simple example of that, and I'm just going to ruin the surprise by saying this is what we're generating. Okay? Generating a very boring, but potentially interesting as we add things on top of it, map. So let's walk through this. And this is also a good opportunity if something doesn't make sense in terms of why the code is doing what it's doing, regardless of maps, like some enter update thing or why are you putting it here, do feel free to interrupt me because these first, well, because they're not first lectures anymore, this bit where you're really learning the enter, update, exit, merge thing is where you want to clear out all of your questions and make sure. So anyway, point is, ask questions if you have any. I am going to talk about, and this is a D3 version 5 thing, that I want to talk about why I put this in a function. But I'm going to leave this to the end, and let's go through the example first. So here we have the very basic, you have an SVG already in your DOM, you're selecting it, and you're taking out the width and height to make sure that your map's going to be in the center. We're creating a projection, very much like we did in that example. And then here we're doing two things to it. One is we're translating it so that when you tell it what your lat long is, you're also telling it, hey, convert it to pixel points and translate it by this much to make sure that you start in the middle of your screen. Scale tells the projection how much do you want to zoom in and out. So it's very similar. So this is what I was saying, that it's possible to zoom, right? Because what that does is pretty much just makes it smaller or bigger. It just doesn't change what's on the screen. So this is the syntax for GeoPath. So this is going to be a function. Path is now a function, and it uses the projection that you specified. So it takes in lat long points and returns the points on the screen. So this is your magic conversion there. So we're going to load in our JSON file with US dates and save it into JSON. And then here we have the very simple enter update, not update actually, just a very simple enter and append of the path where we are going to create one. I was going to ask you, I just realized the comment has the answer, so never mind. But one path per feature, right? So here we're putting in the JSON.features, and that means that it's going to draw the line for one state and then draw the line for another state and draw the line. These are separate things that they will overlay each other, but it's semantically makes a lot of sense. And then that's it. That's pretty much the code. Excuse me. And then I call the function here. This is something I've commented out only just to really show what that does. Right now, this is just a map, but you might want to add in the lat long lines, and so that's what Gradpool does. Weird word. Out. And wait. No, I didn't wait. Say that again?
Practicing outside of it.
Yeah, it doesn't update. That's weird. No, it had updated. Let's see. Oh, it's on the page. It's just,
You still can combine
let me see what network
them.
on
I just did it.
Maybe. Well, I'll come back to that because I do want to show you what that does. That adds the layers. Do we supply that in homework? Sorry.
Nope.
We don't. Okay.
That's a question.
Cool.
That's
Cool. Cool. Because if they don't have this all on their laptop. Cool. So that adds the credit. Okay, so the basic, we have the map. Now we start getting interesting because we can add stuff on top of our map, right? Whether it's the amount of rainfall, whether it's the, whatever it is that we want to encode, we can either color it or add separate markers. We're going to look at two separate examples. The first, we add a marker on top, in this case a circle. And the second one, we're actually going to color the actual path for the state. Yes, go ahead.
Can you do transitions with that path function for
Yes.
the maps?
So, no, you can do transitions, what do you mean with the path function?
I mean, so it draws each individual state and animates it while it loads.
Yes, you can in the same concept. This is a path like a line, right? So what you would do, let's suppose you wanted to morph it from Utah to Boston. Boston is not a state.
Massachusetts.
Thank you. I'm from there, I should know that. I've never played the Brazil card, which I do, because I'm Brazilian, and so I don't know all the states. So anyway, if you want to transition between one shape to another, you're just doing a dot transition dot attribute D path, and it will transition from this shape to the other shape. It's just a different way of generating that string.
What was the example that you saw earlier with the transitions between projections? All it does is switch out the projections and then it does the transition as we had before for simple shapes.
Oh, yeah. Okay, so let's see how we add markers on top of our map.
I think it was another question.
Oh, sorry.
You can go ahead.
For the async and the wait, what does that?
Oh, yes, thank you for reminding me, yes. So, the idea here is the following. So in version 4, this was different. So in version 5, the way that you call D3.json or D3.csv returns a promise. I talked about promises already, right? No. So the point is, it returns this thing that you have to wait for. And it's asynchronous because it doesn't know how long it's going to take to go to your server, get your data, and come back, right? That pretty much means that you can't guarantee that it happens instantaneously. So we have to say, wait for this data to come back. When it does, continue, right? But the fact that there's an await in this script means that you can't just run the script like this. You need to wait for those things. So the await function can only live inside an asynchronous function. So instead of just a script, the moment we're going back to the server, we need to wrap this in an async function and then immediately call it if we want to render it. So in this case, we're creating an async function called USMap, and then once we finish defining it, we call it. Because of the new syntax, we're going back and grabbing different things. There was a question? Yeah.
Yeah. So I know we did this in the last homework. So path is I guess like a generator. So
Yes.
it's a reference to a function,
Yes.
kind of. So then when we're mapping JSON.features in the data binding step, attribute of D of path. So that's like calling the function on every data element of JSON.features
That's exactly what I was doing.
and then shoving it into the D element of whatever path you're doing.
Yes.
Okay.
Yes. And I'm going to repeat that, because actually I'm glad you brought that up because it's not entirely intuitive. So what he said, and which is correct, which is we're just giving it a function here, right? You're not giving it the input right there. You're not saying path in parentheses JSON.features, which you might expect. Because when you do a .data JSON.features, you're pretty much saying for each one of my paths associate this data. When you go say attribute, let's suppose we did attribute color, right? If you want to do attribute color, you say D and return D.color. Let's suppose that's an actual attribute, right? In this case, the argument to our function path is the exact data. So you could write out D return path D. This is the short syntax. This is the same thing as writing this. And D is unfortunate because D is the name of this. So let's suppose we said data. This is the same thing as writing. But because it's just saying, hey, take the thing that's bound to it and apply this function to it, there's this shorter syntax. Thank you for bringing that up. Any other questions? I'll set one aside to. Okay, so, we're going to add circles on top of our map now. So here we have a very simple SVG, and we created a map layer and a city layer, and we did that to ensure that the map is behind the markers that are going to go on top, right? So the city layer is on top. That is a nice, clean way of separating things out. When you want to make sure that something's on top of something else, is create divs and then make sure that the order of them. If you didn't want for any reason, didn't want to create separate divs, can anyone tell me what is the rule that defines what's on top and what's on the bottom when it comes to SVG elements?
Is it Z-index?
So Z-index, people use that, but there's a simpler way, or, go ahead.
Whatever is refers to the label.
Yes. So the order of stuff in the DOM, whatever's in the beginning is behind whatever. So if you wanted, you could do the whole enter, update, whatever for the map, and then for the cities, and they would be on top. And that works if you have like 2 or 3 things. But if you're doing separate layers, several layers of things, and you want to make sure, that's a nice way of doing it, is define your groups in the order that you want them to be in your DOM, and then you can just add and remove stuff from those groups as you like. So similar to what we did in the other one, here we have an async function called cities. So we select it, we set its width, or we get its width and height. Very similar to the other one, we have the same projection and the geopath. So all of this is the same, right? This is what we just did. Now the next thing here is we have a separate file with US cities. Did I show? Oh, sorry. Let me just point out what that looks like. Yeah, here. So that cities is a CSV file that has a row number, which can be used as an ID, the name of the city, population, and lat long. Sorry, not a row number. The rank is right there. So what we're doing here is we're loading in our CSV file like this, and then we are doing this. And I want to take some time to look at this because this works. This will work for this example. This is a very simple way of doing it, but this is not how you do it in your homework, and I want to know why. So let's first walk through what it's doing. Selecting all the circles, we're associating the data that we just loaded in. For every new data point that doesn't have an associated circle, append one, and then set your Cx using the projection function that we wrote, your Cy, the projection function that we wrote, the radius, the fill, and the opacity. This will work until what? What happens if I have a revised ranking and I actually changed New York's no longer number one, and I added one, I removed one, what happens? It's also nodding heads, surely.
So your enter and your exit and your update will all be different.
Yes.
You won't remove or add objects depending on what you're trying to do.
Exactly. So this is an example that we try not to make it too complicated so this works, but I really want to point this out because I think this is the number one thing that trips people up. And we even talked about this, whether we should update the lecture material to actually almost complicate it so that you only ever see the right way of doing it. But I just want to point out that what you're doing here is you really should end that enter here, right? So you would say that is what comes next? Before we do the dot merge, we want to do one thing. And I've gotten this question before. Does it matter if you do circle enter dot merge circles or circles dot merge circles enter? I actually usually do it the other way around, but it doesn't really matter. Now, circles dot attribute Cx and Cy, right? It's more lines of code for the sake of the example, but I do, this is like it's a very simple thing to do because you saw it in lecture and it works the first time. The moment you change your data, it doesn't update properly. So just wanted to kind of point that out. Great, I didn't break it. It's always treated live code and then break it. Trust me. Okay, so then that's what that looks like, right? So now we added a circle for each state, city, top cities, and we size them according to their. Right. There is a part of this. These commands right here actually could live here. Can anyone tell me why? Why is that not wrong?
You're not binding any data to them, so they're just static DOM attributes.
That is the big distinction. Usually for, it's a very personal thing, right? Usually the way that it's easy to remember is you only style after you've merged. Because that way you know you're styling the correct data. But that implies that you're using the data to style, right? So if there's anything that you're doing like the opacity or something that doesn't require the data, you can style the ender selection. That's the rule, but that is not wrong. So you can choose how to do it, but just so you know, if you style everything together later, it works and you don't run the risk of not styling it correctly with the data. Okay. Let's talk about a slightly more advanced example where instead of adding markers, we're going to color the actual states with some value. So here we have our agricultural output data. So for every state, we have a value. Very simple, right? And what we want to do is join the data that we have for the geography with the data that we have in this external file that we got from somewhere, right? Does anyone have a guess as to where we're going to store this agricultural data in the geography data?
Not sure.
Feature dot properties, right? So this is one of the nice things about features is that you can just shove as much information as you want per feature. And then it drags along with it because it's part of the data. So by the time you get to the part where you're rendering it, you have access to all the data that you got. So it's kind of this initial step where you put everything into one data object, you bind that to your country or your states, and then you can use that to style it, which is what we're doing here. So I will skip through all of this stuff, which we've done. Okay, first new thing. We are going to create a color scale. We can define the range here, and then we'll define the domain once we actually get the data, right? Sometimes it's a little hard to remember. Domain is what comes in, range is what goes out. So at this point, we haven't loaded data, so we don't know what comes in, but we know that whatever it is, we want it to fall within these 5 bins, and these are the colors that we want it to be. So we load in the US states data, and then we separately load in the agricultural data, right? Now, as soon as we have the data that we want to color by, we can set the domain to the min and max of those values. Here, as you saw in the format of the data that we're looking, it's a CSV file that has the state name and the value. So we need to bind that with the geography data. One way of doing it is every time you run into a state, go look for it in the agricultural data. It works, but that means that for every state, you're filtering through the entire array. So this step here is not necessary, but it just makes it a little bit easier. We're going to create a little dictionary. A dictionary that has as the key the state names and as the value the agricultural output. Okay, so that is what that one does here. So we go through every state data element, and for each one, we create a dictionary. So this is the key, this is the state, and the value is this. So this means you're going through the whole thing once, and then afterwards, when you go to bind it to your geographical data, it's one lookup. So it just makes it faster and smarter. This is what we were talking about earlier. So now we go through each feature, and we look up, hey, what was the agricultural output for that? And then we define that the properties.value is equal to that. Value, I guess, is kind of an unfortunate name because it can be the value of anything. We could make it smarter. But I just wanted to point out, like I said earlier, the properties object is an object, so you can call it whatever you like. So in this case, since there's only one thing we're associating to it, we call it value, and then we associate the number to that field. Now, this is very similar to what we did with the circles, right? But instead of adding a separate element, we're doing the same thing that we do to just draw it, and then this extra line here colors it according to that value, right? So we got two separate data sources, we merged them into one, we did the data enter update, and now we have that we can use to color, and it looks like that. So that's pretty cool. Okay, so we talked about, this class goes until 3:20. So that's the data maps part. Now we're going to talk about street maps. I'm personally less excited about street maps because I feel like you don't have a lot of control that you do with data maps, but they are a nice, easy way, and you can still do stuff to them, just less so than the data maps. But then what you get is you get the panning and you get the zoom. Imagine if you want to implement panning and zoom for this one, you need to put a button in that when you click will change the scale. Maybe it's outside, so you just have to manually code that stuff up. But like I said, the purpose of these kind of data maps usually isn't to navigate, and it's just to tell a story. So let's start looking at Google Maps. Let's see if we're going to do an example. There's more than one possibility. You can use Google Maps, you can use OpenStreetMaps, right? They all provide APIs that allow you to create a map, tell it where to center it, and then you get all the zoom and panning stuff for free. This is an example of a really ugly, but this is a map that shows you where the pizza is in New York, right? This is an example of one where we do want Google Maps, because if you want to find pizza in New York, you actually want to be able to zoom in and see where it lives, and see where the restaurant is, and what is the distance to your house, and so forth. So in these cases, you don't want to make a data map, because this has already been done for you. But within the visualization world, it's more often than not, you stay away from Google Maps. Okay, so I'm going to kind of tell you what the list of things that you need to do to get one up and running, and then we'll look at an example. One of the first things is to get an API key that pretty much limits the number of times that you can query the Google Maps API without before it saying, hey, unless you start paying us, you're querying us too much. So you get like a free thing where you can query some X number of times, but if you're like a business or you actually provide a use for it, then you need to pay for it. Okay, so you get the API key, so in this case you can, I'm sure if all of you use the one that we provided in this example, it's still fine. We want to make sure and load up the map API using a script tag. We created a development that we're going to put our map, and I want to point out that you need to create, for every map that you want on your visualization, hopefully you don't have more than one, but if you did, you would do this whole process separately, not the API key, but you create a map instance in a separate div. So this is a per map set of instructions. You create a div, and then you call the Google Maps.map to create it. So it's all kind of meta. Let's actually step through and see what that looks like. This is a neat little trick where you don't actually have to set the actual width. You can just say, hey, take my map div and make it as tall as my pages, and that way it'll take up the whole page. So just some styling things. So this is a very simple map. This essentially is the code that you need. Right? So you're just pretty much saying, hey, give me a new map. This tells you what element to put it in, what div to put it in. I don't know if you guys remember, it probably feels like a while ago when you didn't use D3 and you just used the kind of the DOM API, and that's how you would get the map div. And I know it says it up there, but does anyone know off the top of their head how you would get it with D3? How do you get the map div? Yes, select with the dot or with the hashtag. So instead of doing this, you could have done this. Now, I want to point out that if you're using D3, D3 returns a D3 selection. It doesn't return a DOM node. So you would have to do the dot node after it. So this is equivalent, if you wanted to do the pure D3, as that. The reason I use this is that I didn't want to include the whole D3 library for that one line of code. But just so you know, the two are equivalent. The things that you need to set are the latitude and longitude that you want the center to be at, and the zoom level. Those are the only two things that are really required. So here we're centering in Salt Lake City with a zoom level of 8, and it looks like that. Just for fun, I changed it to my hometown. So if we change the center to Sao Paulo, that's what that looks like. And we can change the zoom level. So we want to get a little closer. So you saw it was one object and one line, and you get a map that you can zoom in and navigate and stuff like that. And you can add overlays, which we're going to talk about as well. So this does have its pros. Another thing you can change is the map type. There's a lot. There's satellite, terrain is this one. Looks kind of cool. Depends again what you're trying to do with it. So there are a lot of little things that you can customize. But that essentially is how you create a Google map. So now let's make it a little more interesting by adding onto it an overlay with something else. Actually, before that, let me just walk through a few of the options. Okay, so this is actually just the description of what we just walked through in our example.
I have a question.
Yes.
So when you're talking about the node, why would you return a node versus like otherwise?
Sorry. I was talking about the difference between
You have to
this.
select, select the map and you do like select all and stuff. So if you return the node, like what's the main, I guess, reason for that?
Sorry, I don't think I quite understood the question. You mean why do I do that this? This
Yeah.
right there? Because what we're giving it, remember this is not a D3 function, right? This is a Google Map function. Google Maps and D3 are completely different languages. So what you're pretty much doing is saying, hey, get me this thing in D3 land and then translate it to an element that Google Maps understands. So yeah, so just because if you pass in a D3 selection to Google Maps, it is by new.
Awesome, thank you.
Okay, so this is pretty much just explaining what we saw in the example. And this I just wanted to give you a quick cheat sheet without having to look up the documentation. The zoom level, right? What is 8? How close are you at 8? Is 200 a valid zoom level? So here we just give you a ballpark figure. 1 is as zoomed out as you can get. 20, is it zoomed in? Let me try 21. Oh, that does very much. I think that the difference is, maybe it caps it at 20. Anyway, let's see if that changes it. Yeah, that looks the same. So 20 is probably as close as you can get. Yes. Yeah. So you get all this stuff for free. That's pretty cool. If all you need is a little, hey, this is where you are. For example. Yeah, I think so. Yeah, this is being rendered. Yeah, you can do street view, right? That's the street view.
Oh, man.
We're going to look at the maternity hospital at Praça da Sé in São Paulo. But the idea being that this is being rendered only with this bit of code. I'm pointing to my computer as if you could see it, that bit of code, right? Yes.
So you need to ensure that your Google Maps script loads before you can create the map object. How are you doing that in the code?
Sorry, ensure that.
So you are creating the map object using Google Docs something. So you need to ensure that the script, the Google Maps script loads, otherwise you will just get Google is undefined.
Yes. So you're talking about the fact that this must have loaded, right? The way we do that, that's a very good question. Notice that I didn't run, like the other examples, I did function async and then I called it, right? Because I had complete control over everything I needed inside that async function. Here what you do is you set your init function, but then you pass it as a callback to that script call to say, hey, once you've loaded up, run this. That's a very good question. Okay, so those are the 2 levels, and then there are 4 different types. The satellite view, which we all know from Google Earth. Hybrid has a little bit of the satellite view, but also it draws the roads on top. Terrain I showed you, and road map is the more boring and useful one. There are ways of making Google Maps look way cooler than it does, and not like a Google map, which oftentimes is the goal. So I want to show you 2 things. One is this link to how the whole documentation on how you style your map. You can make it this night look, you can change the colors and everything, and you do that by setting these objects, like the style objects. It says, hey, for everything that's a river, color it in blue, whatever it is, right? But this is kind of a pain to learn, it's just one more notation, so what you can actually do is use this. This is a little styling wizard. So what you do is you can select kind of these different styles, but you can actually go into options and you can customize the shit out of this. You can change the color of the label of landmarks that were only created, yada, yada, yada. So this is pretty cool, and I've used this when you want like this rapid turnaround, you just want a map and you want it to look cool. So this is a page that I actually use quite a bit when I want to have like, okay, I want half an hour when I'm done with this, and just to kind of create a prototype. This is really cool. So I linked to both of those from there, so you can get to that from here and here. So I'm not really going to go into how you can style, because as you saw, it's pretty easy, but you can, which is pretty cool.
So you can export your like settings, which can then be used, right?
Yes,
So
exactly.
that's kind of what
Yes, exactly. That's a good point, thanks. You style it, and then you export a JSON file that says, this is what I want, and then you set that as the settings when you create your new map. Okay, so in order to make Google Maps really interesting for us as data visualization people, is to add overlays, right? And I'm going to scroll down to, before I explain everything, I want to scroll down to the example that we're going to be looking at, just to show you. So this is all the hurricane tracks with where we colored Hurricane Katrina. So this is all hurricane tracks dating back to, I don't remember exactly when. And so we're able to do something similar like we did with the data maps, but on top of a Google map, right? You still are bound to representing shapes the way they are in Google Maps, so Utah is always going to be drawn in the exact place and size that it is in real life, but you can put stuff on top of it. So not the worst, kind of pros and cons. So let's talk about how to do that. Okay, so what we're adding here is called an overlay view. An overlay view tells Google Maps, hey, you can draw your thing, but give me a separate layer where I can put my stuff. Okay? So you're going to create a new overlay view, and then there's a ton of functions that you can, but you don't have to implement. And I just actually highlighted the ones that we use for the example. We have a draw function, which pretty much draws whatever it is that you want to draw in there. The get panes, I'm going to talk a little bit about what panes are. Unfortunate name, I realize this thing out loud. And we need it to select where we're going to add our stuff. The projection, because Google Maps has a projection. We need that so that we can make sure our points fall in the right location. On add is similar to a constructor. It gets called once, so if you want to add like an SVG that you're putting all your stuff on, you only need to add that SVG once, not every time you move the map around. So that would be on add. On remove, if you were doing something that you were to close the map or something, you're telling Google Maps how to get rid of your stuff. And this pretty much tells you, okay, I've created this overlay associated to this map over here. You have 5 different options of stuff that goes on top of your map. And I think it's interesting that they order these alphabetically instead of the order they're in. It took me a while to realize that this is the order they're in. Pane 0 is at the bottom, pane 1, pane 2, 3, and 4. The one that we care about, I know I highlighted this one, but I recently realized looking over this material that we actually want mouse target. I won't go into what each one of them is. The point just being that the mouse target, as the name implies, is close enough to the top of the stack that when you click on stuff, it detects those mouse elements. When I first generated this lecture material last year, I added everything to overlay layer, and it shows, but it doesn't detect mouse clicks. because there's a layer on top of it. So now we're adding everything to the mouse target layer, and that just means that if you wanted to interact with it and make it that when you click on something, something shows up, then that's why we're adding it to this layer. Of all of the functions, the one that we care about in terms of going from projection to lat long, so this is the equivalent. Can someone tell me what is the equivalent D3 function that we saw today that is the equivalent of from lat long to div pixel? Yes, projection, right? So it does the same thing, but it does it in Google Maps world because we don't control that part of it. So we've outsourced that to Google Maps. So this is the equivalent of you telling them, hey, if you try lat long, you tell me where does this go on the screen. So I'm going to skip the description on how to do it because we're going to walk through the example. But you can obviously go back and read it. So this is the data that we're looking at. Did I say? I don't think I did. Sorry, I don't know how far back this goes, but this is data for hurricanes from the NOAA website. And it's pretty much a CSV file that has a serial number, a year, basin that happened in, when it happened, and so forth, latitude, longitude, and so forth. And this is what the code looks like. So here we have some styling stuff that we can ignore for now. And then here we're back to doing the, async function. And we create a map, we set the center, the type of satellite, we can change it to anything we like. So here we're loading in the data, this data, Katrina.csv that has what I just showed you above. Now here's the new stuff. So we're going to create a new overlay view. And then we're going to start setting functions on them, the on-add, the ones that we just talked about. Yes?
So can you repeat what awareness is for?
Yes, I can. So the idea being that there are some functions that only happen in the browser. So if, when you say select this div and make it red, you don't need to go to the server to do that, right? You can just do that in the browser. There are some functions that require you to go get data elsewhere. They're called asynchronous functions because there's no, depending on how fast your internet is, depending on whether the server is down, there's no reliability. You don't know where that data lives. Await pretty much says, hey, this is an asynchronous function, so wait until it's come back with the data and then continue. If you don't put the await, it doesn't give you an error, but what happens is you have a blank page. Because what happened was you said, hey, give me the d3.csv. It went out to get it. Before it came back with the data, you ran all of the rest of your code with no data. So that await is very important. So okay, so you created a new overlay. The first thing that we want to do is this on-add, which is, like I said earlier, is the equivalent of a constructor. So you're saying, hey, the first time you add this overlay to my map, which will only happen once for every map, go ahead and create a new div and give it the class hurricane, right? Whatever you put here will only happen once. So if you put all your draw code in here, it's only going to happen once and will not update. You're going to pan, and your circles are going to stay, or whatever you're going to say. This one we don't really need, and I added it actually right before today because I was reading through the documentation to make sure I didn't miss anything, and they say it's required. It didn't break last year, we're not having it, but that's why I put it in there. It just says, hey, if you're going to ever remove this map, just go ahead and get rid of my div. It didn't break it without it there, but I thought I'd put it there just to be more consistent with the documentation. And this is where the equivalent of our draw or update function would be, which is where we're saying, okay, every time that the user does something, pan, zoom, whatever, call this, okay? So here, we're getting a projection, and we're calling it projection. We're picking a hurricane name, so we're just pretty much saying we're going to focus on this one instead of typing in Katrina, we saved in a variable name. Here, we're filtering out only the hurricanes that happened in the North Atlantic, so we're doing that based on the data. Here, we're just renaming this because it took me forever to realize this. You see how there's a space here? Say that again? Oh, yeah. The point being, I didn't like that huge string, so I just renamed it to d.wing. That's all it's doing. If you wanted to call wind WMO, that would work just fine. This is something we're doing because of the thing we were talking about, what's on top, and what we want to see and what's hidden. We have all these circles, and they're going to be overlaying each other. I wanted to make sure that all the Katrina circles were on top, and there was no track that was on top of it. So by sorting the data, I make sure that the SVG elements are going to be appended to the DOM in the order that I want them to. So this is kind of a way to make sure that you don't have to create a separate group for Katrina, put that group on top. So this is kind of a understanding that the order in which they're created dictates the order they show up on your screen. So we're creating a color scale, a wind scale, based on the data. So this is similar to what we did earlier with the cities. We create the domain based on the data, and then we know that our range is going to go from 2 to 10, for example. And then we create one SVG per circle. And this is something I just want to point out in this specific example. I don't think this has ever come up in any homework or honestly even any of the work I do, which is usually you have one SVG and you add one marker per thing that you want to represent, whether it's a circle or rectangle. But that means that you know how big and where they're all going to, your SVG should be. In this case, we're putting it on a world map and we don't know how big this SVG needs to be. So the way that we work around that is we create a tiny little SVG and we put the marker there, and another SVG and marker, and then we transform it according to its coordinates. So that's just kind of a, it's not something we want to see you do, is what I'm saying. Unless you're doing a map, don't create a separate SVG for every marker. Can anyone tell me what this is? What is the function of that? It doesn't matter the size or time, it could be anything. It doesn't matter what, I just want to know if anyone knows what does that function do?
You're expanding individual data points into like a list.
It's a very similar syntax to that. I do know what you're talking about, where you take the data and then you return an array from that. This is not what that's doing. That, you know when that would be is if you were going from parent to children selectors. I think you guys talked about this for homework labs. It's a very similar syntax. That's not quite what this one is. Yes?
Not a function to assign keys to them.
That's exactly what that is. So this is a key function, right? So what we're saying is, don't just associate every data point to a DOM element, associate it and then link them together so that when I do an update, that you don't all of a sudden see your circles changing and moving around. This means that for every, this is like an ID. Imagine instead of ISO time, that was the only unique thing I could find in this data. Well, let's suppose that everything had a unique ID. I'm saying this square is associated to this data, and I know that this data is it because of its ID. That means that when I update it, I promise not to associate this data to a new element. You kind of bind it so that you make sure when things move and update, they move together. So yeah, it's the key function. You don't need it, especially if you're not going to update stuff, but if you are going to update stuff and things are moving around in weird ways, like you're flying off your screen and new stuff is flying into your screen, make sure you have a key function. The only requirement for a key function is that this be unique, because it's a key. Like in a dictionary, right? Okay, so we're appending new SVGs. Here, I'm appending circles, and notice here, I am styling the enter selection, but only because none of those styles require data, okay? So we're exiting if we ever did an update, in this case there is no update, but I just want to make sure that it hit all of the enter, update, exit steps. We're merging, and then here we are styling, and I'm going to show you two different ways of styling. We're pretty much positioning it by setting left and top margins. And then here we're styling the radius, and we're actually coloring it according to the color scale. So let's take a moment to take a quick look at this. I don't think, and honestly, I think this is pretty cool. I don't ever use this .each for this purpose, but I think it's actually and I even prefer for this case this one. So let's talk about the difference. If we didn't have this must look pretty familiar. Oh, I can't do it here. It's not a Studio Code, is it? So while I'm doing this, this looks pretty familiar to everyone here, right? I'm going to the back of comment. So you're pretty much saying, hey, I'm going to style the attribute left and top, and I want to do it according to the data. So I take my data and I create a new, this is just saying for the function that we looked at earlier that will take lat longs and make them to pixels, require that it's a Google Map lat long. So here we create a new Google Map lat long from the values, latitude and longitude, then we do the projection and we pretty much use that value, okay? So what's the problem with this code? I mean, it works. Not everybody at once now. These two lines are exactly the same as these two lines. And that kind of hurts a little bit because it's making a separate calls, doing the projection again. So knowing that we want to set two things based on the data, and we need these external calls, it's not just returning d.latitude, it's doing a separate call. This is what this does here. If you look at the transform function, it takes in your data, does these calls only once, and then it returns, it actually styles it for you. So you pretty much passed in the selection and said, hey, I want you to style these two attributes according to your data. So it pretty much says select yourself and assign your style left and top. So the nice thing is, sorry.
Do we need return?
Do we need return? Oh, you're right, maybe not. I wonder if, the only reason I guess we can find out. So the question was if we need a return. And the reason he's asking this is because all of the actual action is this, right? So inside the function, it's styling itself. So why are we returning anything at all? My only hypothesis before we test this would be that in order for this chaining to work, you know how you do a transform, and then you're also assigning the class marker? The chaining in D3 assumes, like in a functional approach, that you always return something. I think that if you don't return anything, it's going to kill it, but we'll find out. And I'm just going to do this now, because I'm not going to comment. Okay, so first, let's make sure I didn't break anything. Okay, so we have our map here. The question is, and just to make this fun, who thinks that taking out the return is going to break it? Please raise your hand. Okay. Who thinks it's not going to break it? Who doesn't care? Surprising, very surprising. I think it's surprising because my understanding of the chaining is that you would need it to return something.
Each is a function which applies transform to everything, and then each returns this.
Yeah.
It doesn't depend on the transform.
Yeah, I think that, anyway, so now we don't need to test. Obviously. And then we set them up. And so yeah, so this was the last, so if you don't have this one, right, then you have this floating overlay and you have this floating map and they all put together. So this pretty much says, hey, take the overlay that I just created and set it to the map that I created up here. Remember, we haven't really bound the two together yet. So that's what that line does. And then we have a map that we can zoom into and pan. And here, oh, and I actually took this out. Let me show you this. This was something so it's a very simple interaction, just to kind of demo the fact that we are associating this, I'm sorry, I think I actually didn't mention this part. Here, I mentioned it earlier, right? This looks kind of funky, but what it's pretty much saying is, hey, give me all the possible panes that I can add myself to. It could be something like the overlay one, could be the info panel one, the list that I showed you earlier. And then I chose overlay mouse target as the one because it's the only one that allows you to still interact with it. Now, for a very fascinating demo, I'm going to set it so that in every circle, when I click on it, you see what the data associated to it is. And yeah, I think I'm actually going to do, I'll have to do it here. Ignore the Google Maps errors. So now, if you click on stuff, you get the data. Sorry, that's so small. The data that's bound to it. You can see it all right? And then you could do something like, oh, I want to drag it, right? Because the moment you can click on it and select it, you can do anything you could do with it if it were something else. So if you drag it, on drag, you would have to send the API query that says, hey, what's the lat long position? What's the lat long 2 pixel of this location, and this location, and this location, and that would move your circle. Right? So there would be a lot more, like you would have to manually position things as you went along, but the point of this is just to say that by adding it to our mouse target, whatever that was called layer, it allows you to interact with it, which I think makes it much more powerful than just you get a static visualization. I think that wraps it up. I wonder if there's anything I forgot. In the meantime, are there any questions? Well, I guess that means you guys are 13 minutes free time.
Well, thanks, Carolina.
Yeah. voting on you guys. But, so if you guys wanna come up and get some candy, someone is starting to work with you.
That's interesting. There's some really simple questions in Rock's so I think they want to throw a few to know, I don't know, but if there's a coding